All right, I thought I'd briefly, kind of go through this circuit here, which is basically a 723 based regulator, and you can see it's supposed to be 3 to 30 volts, 0 to 3 amp adjustable limit. And, I wanted to discuss foldback current limiting versus linear limiting, but also I wanted to first point out that, remember, this power supply is smoothly variable. If you look at most data book uh, power supplies for the 723, remember they're all meant for fixed output applications. So very few of these, actually have any kind of variable output capability or anything. So the 723, this is what confuses people about it quite often, is that they think, oh, okay, it can do, like 0 to, let me show you here. This is out of the Hazen textbook. Let's see, power boosted, they don't really cover much in terms of voltage regulation, but normally there's like a 7 volt limit, okay, that most people think these 723s have. And, they think you can only vary it, from like, 2 to 7 volts, and then from 7 to like 30 something volts, they think it's split range. But again, that's just because it's from these types of books, which are looking at this as just being a regulator you'd build into a piece of equipment, right, and set it as part of your equipment, be it a stereo or something like that. And you don't want a variable power supply for that. So that's why almost all these designs are based on fixed regulators. This is a really old regulator. It's been around a long, long time. Certainly as long as the 317, I would say. And other even fixed regulators. It's a pretty old regulator. It's been around since the 70s, I'm pretty sure. Um, but it's very versatile because unlike a three-terminal regulator, you can make current adjustment relatively easily. This circuit board, I mean this circuit, you see here, I'm using a Darlington, a TIP 120 as the pass transistor. Again, you'd want a better heat sink than that for 3 amps. That's why I don't test this thing too heavily, because it's just a test circuit. I've built plenty of actual power supplies based around this IC, but this was just a little test board, that I was looking at different power supply concepts with. Um, but as you can see over here, this regulator, is pretty simple, but it can vary. It does not have no 7 volt limit. The 7 volt limit comes from this BREF, which is a 7 volt reference. But again, you can find out on the internet, just like I did, ways around that limit. So this will vary smoothly, pretty much from about a little over 3 volts, up to 30 volts. And, you adjust this potentiometer, to get it to adjust the voltage, and that's the coarse current potentiometer, and that's the fine current potentiometer. So, and you can see I got it, basically I got 37 volts. It's drawing about 3 milliamps right now, and that's the output of it, where it's currently set. So let me, um, start adjusting the voltage setting on this thing. Let's see. Alright. Man, I hate these little fucking things. Okay, there it goes. Shit. Okay, so I'm starting to turn the pot, because I got it set to minimum right now. Damn it. Sure I'm turning it the right direction. I don't know. Okay, there we go. Shit. cheap Amazon pot. It's got a dead zone in it. That's why you saw it go to 0 temporarily, or some flaw in the thing. Let's see, the current's climbing up to 5 milliamps. There's no load on it right now. But, this is a 10-turn pot or whatnot, so, you can go up, get pretty fine adjustment out of it. But as a lab supply, you wouldn't want to use it this way. But, up to 12 volts, let me start turning it faster and faster. Takes a lot of turns. Shit. Okay, come on, get up there. 30 volts, 31 volts, 32 volts, 33 volts. Okay, that's about its limit. It's about 33 volts. Okay, so at any rate, we're up to about 33 volts. So you saw me smoothly adjust that range, from like 3 volts to 33 volts. That's a 10-to-1 ratio, 20 decibels. So, the fact of the matter is, it's pretty, it's pretty useful, and it's up to 20 milliamps, quiescent. Again, I've got no real load on it, where I have it, but, I got the current limit set to, because I got this 100 ohm potentiometer. Let's see what happens when I hook that up to it. It's 25 milliamps, that's where I got it set, but, that pass transistor's, dropping it down to 2.2 volts, at that current limit. So, see how hot the transistor is here. It's still running cool, luckily. That's not much current, so I'd expect that. But let me hook it back up here. Alright, so you can see the LED got really dim when I did that, but 2.2 volts. Now let me try to adjust the current on it, and I'm going to do this quickly because, again, I don't have much of a heat sink on it. I'm adjusting the current down now, down to 20 milliamps, so it's going down to 1.4 volts, 1.3 volts, at 15 milliamps, 1.2 volts. So, as far as its current limiting is concerned, yeah, it adjusts down quite a while. Shit. I'm going back up the other way. God damn it, this stupid thing keeps slipping off here. Shit! I hate these fucking things. But let me adjust it the other way. Okay, so we're up to 50 milliamps, and you can see the voltage increasing. 84 milliamps, 95 milliamps. I'm gonna back it off because, again, this isn't much of a heat sink. Get it back down to lower levels here. Okay, but I'll just detach my load here, and alright, so we're at, back up to 33 volts, so bright and shiny. So anyway, but that's linear current adjustment. Of course, this is my fine adjustment. That corresponds to, in the schematic over here of of this, let's see, this potentiometer right here, that's the fine adjustment. This is the coarse adjustment. This is actually being used as a potentiometer. This is a rheostat, how I have it configured. So, oh, by the way, if you're curious, here's the circuit board designed to it. So, I really didn't have to modify it much, so, if at all. But yeah, that's what does that. And here's the voltage arrangement. And the trick to getting this to span that level is this voltage divider here. That's what allows me to go from 3 volts to 30 volts without having to worry about any 7-volt bullshit. So, I just wanted to kind of point that out to, how do I get out of this mode? Stupid full screen. Oh, give me a break. Man, Microsoft sucks. Now I'm stuck in this mode. How do I get out of this? Should be escape. There we go, piece of shit. God, Microsoft sucks. Anyway, the fact is that, it's a pretty cool little deal, but like I said, that's linear current regulating. You could take this thing and actually, put proper potentiometers in it, for a panel mount, pots on it and stuff, and actually use this as a power supply, of course, with a way better heat sink. And you'd have a halfway decent little lab supply that's quite adjustable, as you just saw. And again, it should go up to about 3 amps, but really good heat sink's advisable. I'm not even sure if this particular transistor can handle that, because I didn't intend on running it that high. It might. So I would have to review the circuit to make sure of it. I know this could do 1.5, 2 amps easy. But it's a good little power supply. Now, you may have heard of foldback current limiting, and that's very popular with a lot of these, and you hear that term out on the internet. Foldback current limiting you should only generally use if it's part of an internal piece of equipment that you don't want to have fail. You would only use it in a laboratory power supply if you really needed to cut the current back quick. And that's the only time. I have one laboratory supply, okay, that I purchased a long time ago from MCM Electronics, from Tenma brand. That's it's like a 20 volt, 0 to 20 volt supply and 0 to 40 amps. And that has foldback current limiting in it. Now, the thing's heavily fire damaged, so most of the time it doesn't work, thank God. But, unless you get into it and joggle some pins, because everything's really pretty bad in there. But the power supply itself still works, despite all the smoke damage. But the fact of the matter is that it has foldback current limiting. It's a pain in the ass when I do get it to work, because the moment you exceed a certain current limit, well, the damn thing shuts down, so you got to remove your load. Alright, you sure as hell can't use it for any kind of constant current source based testing, because it don't work that way. It doesn't have a constant current source mode in it. But again, with 43 amps, you might want that, as an option. But, that's the only lab supply I have that has that annoying limit in it. And it is just a pain in the ass. And how do you set it? I mean, since it's foldback current limiting, how do you tell? The only thing I guess you can do is load it with a high current and then adjust the knob until the thing turns off, I guess. So, you got to turn the current all the way up, hook some load to it, and start reducing the current until it kicks off. But it's got to be at the current level you want it. So you're going to have to use a big power potentiometer like this thing, to set it. It's a pain in the ass. I will never fucking mess with foldback current limiting unless there's some real emergency reason to do it. But my advice, if you're wanting to make a lab supply, no, do it more like this. Have linear current limiting in it, like all the circuits, most all the circuits I show you have. But do not mess with foldback current limiting. Don't be suckered into that. You're going to be in for a bad shock when you actually try to use that thing in practice. So I just don't advise it unless it's just a circuit that has such critical parameters that the moment it starts to short circuit, you need it to drop to down to a fraction of the freaking input voltage, very rapidly, but and then you have to reset it every time, but it almost is like an electronic fuse is how to think of it, but you got to replace the fuse by disconnecting it from the load and reconnecting it. Again, it has its place, but if you're after a like I was when I was doing these circuits, if you're after a variable lab supply of some kind that's, cheap and dirty, man, stay away from foldback limiting. I actually built a foldback current limit circuit and based out of the data book. anyway, the damn thing. Yeah, the damn thing didn't work. So, and I didn't give enough of a shit about it to try to figure out what was wrong with it, because I don't like foldback current limiting. I just built it for shits and giggles, but I can't find it right now. But at any rate, it's just not worth messing with. So, anyway, cheers.